So first up, again, I don't really care about that 8 on the outside, but I would like to find a factor pair for 24, one of which should be a perfect square, but the biggest perfect square. So maybe you used 2 and 12, neither of which are perfect squares. 4 and 6 would work. I forgot about 3 and 8, but neither of those are perfect squares either. 5 doesn't work. Yeah, so that's all of them. So which one works on this one? It's the 4 and 6, right? So instead of writing this as the square root of 24, again, I'm splitting it up into its two factors of the square root of 4 and the square root of 6. Why? Because the square root of 4 is 2. So then I would have 2 times the square root of 6. And now I can apply that 8 that's on the outside. Right? 8 times 2, which would be 16 times the square root of 6. So that's just the numbers part of that. But then we need to focus on the letters. There's 2 letters on this one. So twice the fun. I don't want to write out 8 x's or 9 y's. And if you do, that's fine. So I'm gonna go straight into really what I'm gonna use here is the exponent rules stuff, right? So that would be, for example, x to the power of 8. It's the square root. In fact, let's show that part. Square root of x to the power of 8, which is really x to the power of 8, but that square root makes it to the power of 1/2. Now for me, I would just see that as x to the power of 8 divided by 2, which then gives me x to the power of 4. Okay, because we can multiply those two exponents, and that x to the power of 4 is legit. It's by itself. It's not in a square root anymore. That has been simplified. Now that's the x's, but then the y's. Again, we're looking for the square root of y to the power of 9. So again, we look at this as y to the power of 9, but that square root right there makes it to the power of 1/2. 1/2. Now, I'm going to show this a little different because that last way that I did it by splitting it up into different exponents like 2 over 2, you guys hated it, and that's okay. But what I'm going to do now is you can use long division on this. So you can say it's y to the power of, again, I would look at this as 9. I would look at this as 9 divided by 2, long division. And that would be 4 with a remainder of 1. Okay, so why is that important? Because you got 4 with a remainder of 1. That means that you have y to the power of 4. And then the remainder of 1, again, I'm going to show extra steps here, but that'd be y to the power of 1/2 left over, or 4.5, like if you change that to a mixed number. And then that would be y to the power of 4 times the square root of y. Okay, so now I've done all 3 parts on that. So let's start combining stuff. So we got the 16 on the outside. We've got an x to the power of 4. And then I've got my y to the power of 4. Then we got a square root. So we got the 6 inside, and then I've got a y left over. And that's it for this one. So again, if you typed in 8 times the square root of 24, it would have given you 16 times the square root of 6. But the letter stuff you have to do on your own. You're perfectly welcome to expand those 9 y's if you'd like. Again, we've done some of this exponent stuff, so I hope that this isn't so new, or, well, new because we saw it yesterday. But hopefully you feel a little bit more comfortable with this stuff.